So raw real-world data in the form of text, images, videos, etc., usually is very messy, right? Not only that, it may contain errors and inconsistency, but most oftentimes it's also incomplete and may not follow a regular design. In fact, if you look at some of the databases that store this data, they are highly susceptible to noisy, missing, and inconsistent data. Why? Because of their typically voluminous, large scale, rather large size, right? Often in the range of terabytes or petabytes, okay? And this is as a result of data coming from different multiple or heterogeneous sources, right? So what is this data preprocessing? Okay, so data preprocessing can be defined as a step or a process or a technique in data mining, right? And data analysis, right? That takes the raw data we've talked about and transform that into a format that can be understood and analyzed by computers. And also if you're in the field of machine learning, these are very important step. In fact, 50 or 70% of the time, 50 to 70% of the time will be spent on data preprocessing. Okay. All right. So in fact, our first agenda, we're going to be looking at data quality, right? But before we delve into this, let's look at the other components of data preprocessing. We have data cleaning, data integration, data redaction, data transformation, and discretization. So when you talk about data cleaning, right, here you want to remove the noise, right, and correct any inconsistencies in the data. That's the function we'll be performing here. Then when you're looking at data integration, here you're trying to merge data from multiple or integrate data from multiple sources into a logical data store. Most times this data store we refer to as a data warehouse. Okay, and then when we look at data redaction, here you're just reducing the number of features or input variables in a data set. Okay, and some of the strategies you might be using here is like aggregation, right? You're trying to eliminate redundant features, right? You can even apply clustering as a technique here. And then lastly here, data transformation, right? Some of the strategies we could use here is normalization. And when we apply normalization, here we want to scale the data to fall within a smaller range of maybe 0 to 1 so that they're kind of uniform and consistent. Okay, back to data quality here, we're saying low quality data will lead to low quality mining results, right? So we need to figure out how to ensure that our data is of high quality. Okay, all right. So we have a scenario here. So imagine you're a manager at some organization, in our case here, all electronics, right? And you have a task, you know, to review or some of the data stored in that database, right? So your task here is to inspect, right? Inspect the database or data warehouse. You want to identify or select some of the attributes. In our case here, we call these attributes or dimensions. And this, for example, include item, a price, or unit sold, right? However, you find that you have some issues, right? For example, here, the item price is missing for some transactions. So from these dimensions here we've mentioned, we notice that there's some missing price of an item, okay, in some of the transactions that we have. Okay, it could be 10 or 5 or 20, whereas we have missing. Now, this is a scenario where we have something called incomplete data, right? Where you have missing attribute values, or you have missing, you're missing some certain attributes of interest, okay? Data here is incomplete, okay? All right. Another example here, as a cashier, you find a cashier error introduced during data entry. You know, tag that a price of a protein bar is $1 million. We know very well this is not true, right? There's no way a protein bar will cost 1 million, right? Now, this is a good example of noisy data or inaccurate data, okay? Values that deviate from the expected. In fact, by definition, that's what we call noise. The values that deviate from the expected or from the norm, okay? Again, here we have another scenario example here. A banana for some transaction is 4011, others are 94011. So you can see here, we have some inconsistency going on here. So errors of encoding, right? So in this case, our data is inconsistent. On one hand, we have 4011. In another, on the other hand, we have 94011, okay? These discrepancies in department codes used to categorize items create an inconsistency in our data. Okay, we need to take care of this in our later slides. All right, timeliness. Okay, so timeliness is a very important element when we're looking at quality. In fact, before I continue here, some of the questions sometimes you want to ask yourself when we look at data quality here, right? So how can the data be processed in order to help improve the quality of the data, right? How do we create consistent mining results? Those are some of the questions you need to ask yourself, okay? Also, maybe another good question would be, how can the data be pre-processed, okay, so as to improve the efficiency? Okay, we want data that is fast, efficiency and ease of the mining process. Those are very important questions to ask here. Okay, now let's go back to our other, characteristics of data quality. We're talking about timeliness, right? So timeliness here most times just refers to the availability and accessibility of data in making some big business decisions. All right. We all aware that when we have clean and well-organized data, again, this is gonna influence how you make smart decisions, right? And how also you end up having better decisions of what to expect in the future, right? For those who have credit cards, right? We all probably have credit cards. You want to make sure that your credit system, right? You're able to access, or rather, your data, or rather, your report is actually available and accessible in real time, based on your credit card account activity. That's a good example of timeliness, right? Okay. On the other hand, probably something I can think of right now is that companies are required to publish their quarterly results within a given time frame. These are very important issues when talking about data quality. Okay, timeliness, very important. However, if there's a delay in timeliness, right, this might lead to users losing trust in your system or mechanisms, right? In fact, the other two factors affecting data quality include believability and interpretability. Let's look at each one of those, okay? So when you talk about believability, right, this is a factor that talks about or means reflecting how much the data are trusted by the users. How much can we, trust? How much of the data can be trusted by the users? So here we've already lost some trust because of there were some errors, and these errors led to some delays, and these delays ended up again allowing, or rather making our users lose trust, right? In the end, we end up having incorrect data, inconsistent data, and people might end up not using that data. Okay. Another factor here is interpretability, right? Here we mean that want to reflect or show how easy this data can be understood. Interpretable, right? Interpretability. How easy can we understand this data? So if the users can understand the data, then these users cannot use the data. Okay, what is this attribute about? Okay, if we can understand what this attribute is all about or describing, then there's no point of using it. So it has to be easy to understand. All right, very important. So all in all, we are saying data quality is very crucial during data preprocessing. In fact, data quality here must conform to some of these properties. We are saying high quality data must be complete, must be accurate, devoid of noise, it has to be consistent. Okay, consistent data has to be timely. If we say we have to generate reports every quarterly, you can see how also a good example here, if you are to, if your salespeople, need to earn some bonus, right? So if there's a gap here or delay, then it will affect how we award bonus to our shareholders or employees, right? Then it has to be believable, believability. Here we talk about trust. The data must be trusted by users, and most importantly, should be interpretable. Okay, interpretability, how easy it is to understand the data. All right, yeah, and that's data quality. And that marks the end of this first part of the video. In the next video, we're gonna be addressing data claim. All right, okay, thank you.